Ladies and gentlemen, please welcome to the stage Space Foundation CEO, Rear Admiral Tom Zelibor.
Well, good morning and hello again to everybody. It was a great event last night and I appreciate everybody that attended that. I'm now pleased to introduce our next speaker, Pam Melroy, who has served as NASA Deputy Administrator since June of 2021. Pam has attained a formidable combination of skills. She's a fighter pilot, an astronaut, an MIT grad, and in her current role is responsible for defining NASA's vision and advocating for the agency's future to the government and public alike. Clearly an underachiever. She has helped inspire the next generation of space travelers with the successful Artemis 1 launch and recovery this year. Throughout her career, Administrator Melroy has filled civil and military roles, serving as a colonel in the Air Force and as a NASA astronaut on 3 space shuttle missions. All of them were dedicated to assembling the International Space Station. She was one of only 2 women to act as mission commander during the shuttle program era. Administrator Melroy returns to Space Symposium this year with a contingent of more than 300 NASA personnel. It's truly amazing and shows their dedication to this event and supporting all of us. On Wednesday, Administrator Melroy will convene NASA Associate Administrators for the Moon to Mars Strategy Implementation Panel. She joins us today to discuss the future of human exploration throughout our solar system. So please join me in welcoming NASA Deputy Administrator Pam Melroy.
Thank you so much, Tom, and thank you to the Space Foundation for bringing us together for this tremendous event. I don't know about you, but I'm kind of waiting for the other shoe to drop. The weather is lovely. It seems like every time I've been to Symposium, we've had at least one crazy weather event, because after all, this is Colorado in the springtime. But maybe we'll be surprised this year. But it's wonderful to be here with the whole NASA team. So in the year since I last spoke in this forum, we've had a lot of exciting things happen. We released the first images from the James Webb Space Telescope and discovered that the telescope itself is twice as good as we hoped. So we've got 20 years of amazing science ahead of us. So that was extremely exciting. We've made progress on the future of supersonic flight. On the planetary defense side, we launched the DART, or we showed that through the DART mission, we demonstrated the ability to change the course of an asteroid, and that was amazing and exciting to watch as well. On the climate front, we launched the Surface, Water, and Ocean Topography mission, SWOT, with our international partners, and that is essentially going to be the James Webb Space Telescope for the oceans. Remember, we are a water planet, and the water plays a critical role in climate, so we're excited about the outcome of the SWOT mission and what we're going to learn. We continue to learn from our capstone partner what the environment is like in cislunar space in a critical orbit for us, and of course, we successfully launched the Artemis 1 mission, our first test flight in the Moon to Mars program. Very exciting. It was really an extraordinary year, and so many of our partners are here today, so we thank you for your partnership, the work that you did towards the success of all of those missions. We're poised to continue making progress in the coming year, and we're excited about the new things that will be coming. But today, I'm going to talk about our future on the Moon to Mars program and the progress that we have made in the year since I last spoke to you about this. Those of you who have heard me speak before know that I always start with the why chart. I think it's critically important for us to make sure that we're always focused on the benefits to humanity that civil space provides. So starting with, of course, science front and center. Science is our seed corn. It's the seed corn of the capabilities of the future, our understanding of the universe, our understanding of the solar system that we can only achieve by retrieving samples, studying what's happening throughout the solar system. Understanding the climate can only be done from space at scale. We can measure terrestrially, but if you want to see the Earth as a whole system, you have to do it from space. And of course, in our microgravity science, taking gravity out of the equation in microgravity helps us understand our own bodies and physical processes, second and third order effects that we can't get any other way than going to space. Second, national posture. So those are the national science and technology capabilities, critically important. I've got lots of great examples of spin-offs, but some of them have had a tremendous effect on the ability of our country to do critical work going forward. One of my favorite examples is that software engineering as a discipline didn't exist before Apollo. NASA essentially had to invent it. And of course, we know what happened next. That had a transformational effect on our capability in this country. And even the cell phone camera that you're carrying around was developed by NASA scientists to put a camera on a chip to look at the Earth. And now, of course, that has spawned so many other capabilities. Increasingly, we're also seeing our amazing commercial space industry. So all the capabilities that our industry has is really the envy of the rest of the world. But it's also a high-growth industry with a lot of really good, high-paying jobs. And we see interest with our international partners around the world to figure out how to stimulate their commercial space industry so that it can approach the skill set that we have. And finally, inspiration. I don't think I need to tell anybody in this audience how inspiring space is, but it really has proven to have a completely unique capability, especially to inspire the next generation, that other seed corn for us, the students of the future. We know that when we talk about the work that we do to students, how it inspires them and excites them. And we are thrilled that through our Artemis program, we're going to provide opportunities for girls and students of color to actually see themselves in the future. Because if you can see it, you can be it. And that's critically important, and it's a unique aspect of what we provide as civil space. So, one of the major things that we did this year as well, I announced our initiative last year talking about the Moon to Mars strategy and our objectives development. We did a tremendous amount of work consulting with industry inside the NASA workforce and our international partners to refine that strategy and, more importantly, to refine our objectives as well. We formulated what we believe is a politically and technically resilient strategy, and the objectives flow from it, and they will be our guideposts. Those objectives will be what we need to focus on to ensure that humanity can move from the moon to Mars and beyond. And this time we plan to stay. We learned so much from the space shuttle, but a lot of the science was just tantalizingly short, these short duration missions. And that's why we built the International Space Station, to get more science. But what we also did was we proved the ability for humans to live for longer and longer periods of time in space and how to support them through that. So now we need to apply that learning and get ready to go to the next destination. These objectives form the wireframe, as we call it, which connects and advances our goals to move towards humanity's next frontier. And they set the foundation for the architecture development that I'm going to talk about today. So the next activities that we have done after developing the objectives: consultation. We showed how we changed the objectives based on that consultation. And our strategy is committed to a very robust systems engineering and consultation process. And I'll talk about our 5 methodology principles in just a moment. So we recently combined all this into a single report. So there's the QR code. You can see the description of how we developed our strategy, the principles that we have, and of course the objectives that came out of it. So we're really at a historical pivot point. Industry has proven its ability to do things that once were the province of governments, and it's now extending our space economy from low Earth orbit all the way to cislunar space. Our global partners also seek to explore the moon, and we will return together. You may have seen recently the announcement of the Artemis 2 crew. Very important to us that that crew had an international partner, Jeremy Hansen, an astronaut from Canada with us. So that is, if nothing else, you can see visibly that we are going and we're going together. And we're also going with public-private partnerships with industry. So today, I'm talking about the next phase of our plans, but first, a little bit more detail on the objectives. First of all, the goal, the bumper sticker is what we call this. Our goal is to create a blueprint for sustained human presence and exploration throughout the solar system. We believe this is what the American people expect of us. This is what we have dreamed about for years, decades, maybe even millennia. Going out to explore, because after all, humans are a society of wanderers and explorers. It's in our DNA. I just want to say that the objectives are aimed at allowing us to develop that blueprint for the activities that we do on the moon, and then we're going to go demonstrate that blueprint. What order do we need to do things in? How should they look? What are the key elements of the architecture? And then we're going to be able to demonstrate that on Mars in preparation for the next destination and the next destination after that. There will be differences in each destination, but having a blueprint allows us to have a repeatable approach to going out into the solar system. So this will essentially serve for us, these objectives that I'm going to talk about in a moment, kind of fulfill the function of a decadal survey. Our science community is blessed that the National Academies brings together the science community and provides guidance for the decade of science ahead. This is essentially the same thing, except that it goes far beyond one decade, because human spaceflight requires that. So that's our intent, is these objectives serve the same purpose as a decadal survey. We know that they will evolve as we learn things, but we think that they will provide stability to come for a significant amount of time. Of course, science has to be front and center. When we went for Apollo, we discovered that we were following a mission to send a man to the moon and return him safely to the Earth, and we found incredible scientific riches on the moon. Now we need to take a different approach. Science needs to be front and center in what our astronauts are doing, just the same way it is on the International Space Station. The second bucket of objectives is around transportation and habitation, and that's a pretty mature bucket in a lot of ways because we have a rocket and we have a spacecraft. We're working with a partner on a lunar lander, and we're also working with global partners on transportation and habitation systems on the surface of the moon. The next bucket is infrastructure. I just want to emphasize how much we want to get science return out of what we're doing. Now, you're going to send astronauts 3 or 4 days on a trip to the moon, 30 days of science on the moon, and then 3 or 4 days back. That's pretty good return on investment for science. Anywhere else in the solar system, it's not going to work, right? We're talking 2-year journey or longer for a 30-day or less stay. So that's okay for a test flight, but we have to have the infrastructure that supports humans for a sustained presence to really maximize the value of what we're doing to humanity. We really need to be able to stay. And so that infrastructure is a critical element of our architecture. The communications, the power, landing pads, all kinds of infrastructure. What's exciting about that is, as well as we've learned here on the surface of the Earth, infrastructure supports new business models. And we know that there's interest in a cislunar economy, the same way we have an Earth orbit space economy. And we believe that efficient, cost-effective, scalable infrastructure is going to help our industry partners do just that. Last bucket I want to talk about is operations. As someone who lived through the transition from the space shuttle to the space station, very, very different operational methods and very different ways of keeping humans safe and enhancing human health and performance. We know that we will be revolutionizing again what our humans are doing in space, and we need to think about how to enhance human health and performance while they're doing science on the surface of another celestial body. So our guiding principles are absolutely essential. These 5 are very important to us. Now, this is a pretty complex mission, so we know systems engineering is absolutely critical. We've already taken the step of building an objective-based approach. That's very, very important. Second, we architect from the right. We look at the goal. What are we trying to achieve? But we execute from the left. As you know, we have many elements underway already that are critical aspects of the architecture. And what's been challenging is how to figure out how those two meet. And I'll talk about that in a moment. Third, of course, is staying with a consistent plan. It's a constancy of purpose. Being able to articulate that plan helps us stick with it. And then, of course, that articulation of a unified vision is critical for our stakeholders as well. It allows us to have the workforce inside NASA, but all of our partners and stakeholders on the same page. And the lifeblood that runs through this is the enhanced communications and engagement to make sure that we're sharing the plan and we're getting active feedback on the plan, and we're taking into consideration all of our partners and stakeholders' needs and their dreams and their hopes and their capabilities as well. So that's very, very important to us. NASA and our partners have thought about this for a long time, and under Artemis, every year we have been running a strategic analysis cycle where our various programs related to that goal stand, even as we carry out missions today. This year, we held the first ever architecture concept review to link our current activities to the objectives and to lay out a framework for the Moon to Mars exploration architecture that translates those objectives into a durable path. We've taken that systems engineering approach through the architecture concept review and decomposed those objectives into architectural components. This morning, we have released the outcome of this first architecture concept review after the objectives were developed, and we begin to trace components of the current and upcoming work to them. So the 2022 Architecture Concept Review details plans for early human exploration of the Moon's South Pole. It provides more definition for plans through Artemis 4, sets the stage for the first crewed missions to Mars. We will conduct ACRs annually, with each one providing further definition as we mature and as we learn of the Moon to Mars architecture. So you can use this QR code to see the summary document, the 160-page architecture definition document, and supporting white papers. With our architecture definition document, you can see the shape of what we're building and where a lot of things go, but there's a lot of room for adjustments. Our annual concept review process is going to enable stakeholders across NASA and among our partners to work towards these clear exploration goals, and we will be seeking feedback on a regular basis. Just a little word about the white papers, very important from my perspective. I spent a decade outside the agency, and I sometimes wondered, why are we doing it that way? So I asked the Exploration Systems Directorate architecture team to begin to articulate some of the critical trades and assumptions that have gone into key elements of the architecture. This is really important, especially when we're talking to our technical stakeholder community. You can find the QR code for these white papers at our Moon to Mars website and via the iPad, actually at the NASA booth if you drop by. So I won't read each and every one of these, but I just want to share with you, I think that they hit it out of the park in terms of the critical first steps to communicate. There will be more white papers coming, but we started with some of the discussions in certain areas. For example, why we selected the near rectilinear halo orbit, which is really crucial to us to access all areas of the moon in Artemis and other areas as well. I do want to draw your attention to these white papers because in particular I think they provide a very succinct description of why we're doing what we're doing, and especially how the Artemis missions at the moon are going to reduce the risk for future Mars missions. A little bit more about the architecture. Going through this process, I'm going to just set some expectations. Although we made a lot of progress in the first ACR, getting everyone on the same page, we just didn't have time to fully unpack the entire architecture. Our Moon to Mars architecture has been organized into segments that are identified by notional missions or integrated use cases. And they correspond to increasing system and mission scope and allow our teams to break the architecture down into manageable chunks and coordinate with partners. So the first one is human lunar return. The initial capabilities, systems, and operations necessary to reestablish human presence and initial activities such as science on and around the moon. Unsurprisingly, we have a much higher level of detail for the near-term segments, including that one. The next segment is foundational exploration, which is an expansion of lunar capabilities and operations, supporting complex orbital and surface missions to conduct science and Mars-forward precursor missions. Sustained lunar evolution, enabling capabilities, systems, and operations to support regional and global activities in science, economic opportunity, and a steady cadence of human presence on and around the moon. And finally, humans to Mars, the initial capabilities, systems, and operations necessary to establish a human presence and the initial activities and science on Mars and continued exploration. So I think pretty far in the future, but even I know that we're going to learn a lot on the way. So we're not ready to talk about sustained presence yet on Mars because we know we're going to learn a lot from the moon. But we have the shape there. It allows us to fill that out going forward. Human lunar return is happening right now with Artemis 1 and 2 and the hardware that is in work today for Artemis 3, 4, and 5. And future ACRs, beginning with this November to align to our budget cycle, will help flesh out later segments. This is an important chart. I'm not going to read it to you, but I want all of our partners, I encourage you to take a close look at it because as a result of the ACR, we identified some areas for collaboration. The ACR doesn't provide a mission manifest. That's not what it's intended to do. It doesn't produce an acquisition document. So it's decoupled from specific procurements today, but it does help show where we are and where we're headed. And we know how important that is for our industry and international partners to see the shape of the future. The ACR also established a sustainable analysis process that identifies these potential areas of future collaboration. So I think all of these areas are very exciting. We know that we need partners in each of them, and I encourage you to look very closely at those areas of collaboration. I also want to talk about the next step. We committed to our international and industry partners that we would continue to consult, and there's going to be a lot of opportunities to engage. So we've released the architecture, but we want you to continue, first of all, to use existing mechanisms we already have to share your use cases and functions with us, and use the architecture definition document as a roadmap for the content that we're looking for. International and industry partners will also have a chance to provide feedback at forums beginning this summer. And we're also looking at other potential opportunities to leverage professional society workshops to enable that free-flowing conversation between us and our partners. That timeline will give you a chance to digest all of this information, and that will allow us to take your feedback and apply it to the next ACR in November to begin that annual cadence. So I think we're especially interested in hearing your feedback on whether the ACR process was helpful, whether the architecture documents and the objectives traceability truly provide traceability, any additional data, supplemental products that you would like to see, especially more white papers, and clearly feedback on the white papers, and then partner ideas on what's the most effective way for us to continue to engage with you. So there's also contacts at the Moon to Mars Architecture website for you to reach out to for more information. And we really look forward to hearing from you. We're very excited to take this step with you together. So from my standpoint, this first architecture concept review is very exciting. It's the bridge between the objectives that we developed with our partners and decomposing them into an architecture with requirements, and then we can execute from the left. This is a critical milestone for us in our Moon to Mars strategy. We feel very aligned with our partners. We want to continue to stay that way. NASA has positioned this strategy for longevity and success. It's rooted very deeply in a rigorous process, both technically but also consultatively, that is broadly communicated and understood, while also maintaining the highest aspirations. We've got our head in the clouds, but we're keeping our feet on the ground. I hope you can see yourselves in this strategy and how much we value all of your input. And also that you're excited too about a future where longer stays at the moon by astronauts uncover amazing scientific knowledge, but also inspire the next generation and inspire our partners to create new technical capabilities and new businesses. We are ready, and we're excited about where this is going to take us, and we can't wait to see the next crew suit up to go to the moon on the way to Mars. We look forward to this journey together. Thank you.
Ladies and gentlemen, please welcome to the stage, from the Space Foundation, Thomas Doramy.
First, thank you to Pam Melroy for those remarks, and I want to thank you as well as Senator Nelson and the entire NASA team for the amazing things NASA does every day, supporting not only the United States space effort, but advancing humanity across the globe. So thank you, Pam.